to catch up after this good lunch, but let's try it. So my name is Yazid, and I work for Akanho Technical Engagement. And this presentation, indeed, it will be in two parts. So let me quickly introduce the first one, which is related to the DNS queries that go to the root zone, but of course, with focus only on the L root side. Why? Because, well, the way the DNS is designed, of course, we know that it is a hierarchical, infrastructure, and of course we have on top of it what we call the root zone. This is where .za is defined. This is where .com, .org, .africa, .joburg, etc., which are all called the top-level domains, are actually delegated. So the role of Akanho is to do this delegation, and once it is done, of course, the registry operator actually runs the top-level domain. And this is where all those registered domains are actually, also delegated. And of course, from a user perspective, whenever we are trying to visit a website or to resolve a URL, our queries go to a recursive resolver, whether it is the ISP resolver or our home resolver or maybe a public recursive resolver. It doesn't mind. At the end of the day, what the user wants is to get access to his website, right? So the resolver will query its own or look into its own cache, and if the answer is not there, well, it will start some iterations, starting from the root and then move to the top-level domain, etc., until it gets the query resolved. So the root zone is quite important, extremely important. But of course, the caches also play a lot of roles. So not all the queries go systematically to the root, of course. But yeah, many queries actually go. We are talking about around 15 billion queries that go on daily basis to all the 2,000 and plus root server instances that are distributed across the globe. Now, of course, we have 13 organizations that run totally independently, which are called the root server operators. And they have their own strategy of deploying the different root servers instances across the globe. But the thing is that they all bind to what we now know as the 11 guiding principles, which are defined in one of the RSAC documents as the guiding principles that the root server operators all follow to ensure the integrity, of the root zone file. Of course, IANA is the sole entity which, distribute that root zone file, but the root server operators make sure that this zone file is actually available across these 2,000 plus different points. And of course, Akanho is one of those 12 operators. So we have 13 identities, but Akanho is one of the 12 organizations because there are 12 organizations. One of them is actually managing 2 different identities. And in terms of point of presence, we have more than 170 plus different instances across the globe. You can see the different point of presence in Africa. And when it comes to the typical DNS queries to the L root zone, because this is what we can see as the root server operator of the L identity, we cannot, see the traffic going to the other operators. So 78% of all the queries, coming from South Africa to the L route are served by the 3 instances present in the country, 2 in Joburg and 1 in Cape Town. 80% go to the cluster, which is now deployed in Nairobi. It's been 3 or 4 years now that the cluster in Nairobi is operational. And the rest, less than 5%, I guess, is going to different other places. Now, when it comes to the queries that go to the 3 instances deployed in South Africa, 80% is actually related to traffic coming from Africa. And out of this 80%, 85% is local DNS queries from South Africa, which is around, let's say, 70% of this total. And 15% are queries coming from surrounding countries like Zimbabwe, Zambia, Angola, Botswana, etc., etc. And 15% are actually coming from Europe. Of course, we are talking about BGP, we are talking about different routing policies, and this is why you are observing all of this. So very quickly to conclude on this, we can, of course, say that the DNS traffic originating from South Africa to the L route is quite well served. We can see this distribution. And those 3 L route instances that are also in South Africa, we can see that they are mostly serving the local traffic, which is also quite good. Of course, we need to ensure the renewal of those instances every 5 years, usually. And hopefully, we will also be seeing from the local community some sort of additional measurements to dig into some extra, related traffic-related patterns when it comes to the queries to the root zone. That's mostly the takeaway from this first part of the session. I will now hand over to my colleague, Alain Durand, who is one of the distinguished technologists at ICANN. He conducts a lot of research. He has authored and co-authored about 14, 15 RFCs at the IETF. So he's well known in the community, and I hope that Alain can hear us. Alain, over to you if you can hear us.
Hi, Yazid. Thank you very much for this introduction.
Excellent. Thank you. And so we'll be listening from you, a very nice study that you did. And maybe the first introduction will be for you to let us know what the study is about, what is the background, and what has been the methodology that you used.
I will do that. First off, thank you for having me here, and I apologize for not turning on the camera. I had a bit of a medical procedure on my face yesterday, and I'd rather like to not share it. I don't want to scare you away and leave the meeting too early. So Yazid talked about root servers. I'm going to talk about DNS resolvers, either the resolvers running in the ISP or running in public DNS operators like Google, Cloudflare, and others. The difference between observing the root and observing the resolver is that we have access to the root, being one of the operators of one of the root servers, L, but we don't have access to resolvers, and service providers or public DNS operators do not publish any relevant statistics. So we have to look at this from the outside and think of it as a black box system. We really want to measure it sending probes. I've seen a number of queries where we send a couple probes, 100 probes, or thousands of probes. That's good, but that's not enough. We have been working with Epinik and Jeff Houston and Joe Damas, and I'm sure you're familiar, most of you, with his measurement system that's based on Google Ads that sends millions of probes every day around the world. This year, we went a little bit further. We accessed some of the raw data from Jeff, and we look into some of the things that nobody has really paid too much attention before, which is what really happened in the first few milliseconds when a query is sent. So this presentation is a first. This is a study that is not yet published. It's going to be published soon. So you have essentially a preview of it. We have collected data in November last year for about 30 days, and we have 839 million measurement points. So I'm not talking about 1,000 or 10,000, 839 millions. And in South Africa alone, we have about 3.5 million measurement points, which give us some good confidence in the data that we are going to show later. Back to you, Yazid.
Thank you. And what was the methodology, indeed, as you introduced the background of this?
Thank you. So we decided to do two different things. First one is to separate all the queries in what we call fluxes or flow, same thing in same word. So we look at the queries that are coming from the ISP of a probe that's serving the probe. We look at the queries coming from the public DNS or other places, and we do that based on the IP address. So in the past, we were only looking at what is the first one that is coming and forgetting the others. Here we really keep those separate flows together. And what we see, just a preview, many queries are repeated. So we look at those repeats and in different time slots. So first, of course, we have the initial query. And then at the very end, we have what we call the zombies, the same query that happened and it's played again, but more than 30 seconds later. 30 seconds later, the user is gone. Then we have a retransmit, things that happen when there's a timeout on a DNS packet. And it happens usually between 300 milliseconds and 30 seconds. And we have things that happen very quickly in between 0 milliseconds and 100 milliseconds. So this gives us 4 different categories that we are going to analyze in detail. We also, of course, look at Quad A, HTTPS, but that will be for another presentation.
Interesting. And what are the patterns for South Africa?
So I hope you can see this slide. There's a lot of it. So we have, as I said, 3.4 million queries that we have analyzed. We see that about 68% of them are really coming through the flux of the ISPs, and 31% are coming from the flux of public DNS. It's split between Google, Cloudflare, and the others. What we see overall is the zombie rate is relatively low. It's like 7%, what we see on the right-hand side of the graph. But what was curious to me is the middle part to the right, which is the things between 300 milliseconds and 30 seconds. And here we see 126% of the queries being replayed on what we would expect timeouts. This is extraordinarily surprising. I would have never, ever have thought about something like this. We expected a few percent, like packet drop, packet loss, but 126% average, this is a lot. That's the overall picture for South Africa.
And can we break this down in different operators? I hope they won't.
So I'm going to go into some examples of profiles. And because this is just a preview, I've anonymized the data. So I'm not going to call names or anything like this. If you are interested into knowing more about your own profile as an operator, please contact Yazid. This is one profile out of many. It's a profile that serves about 500,000 probes. What we see here is that on this service provider, 96% of the traffic goes to the ISP resolver. Only 4% goes somewhere else. This is typical from some profiles that we see elsewhere in Europe, in the US. So, and you see that zombies, yeah, 0. Repeat on a packet drop, 1%. Repeat quickly, 2%. So there's nothing to see here. It just works. It's just great. Let me show you another profile. This profile also use mostly the ISP So 62% of query goes to the ISP, another 37% goes to public resolvers. But the queries on the ISPs that are in blue are repeated within 10 milliseconds and 30 milliseconds. So if you total this within the first 100 milliseconds, we have 91% of the queries that are being repeated very, very quickly. So every single query is repeated. Is it because there is a farm of resolver and both resolver and the farm are sending the query? Possibly. We have some data that seem to indicate that on average for this resolver, for this ISP, we see each query being sent by 1.94, almost 2 IP addresses. So it seems that that ISP has configured his resolver, and there are two of them, and both of them are doing the work at the same time. That's why we see all the queries being repeated. Let me move to another example. This one also is 95% doing all the work himself, but nothing is repeated immediately. But look at what's happening toward the right. Everything is being repeated, and if you total everything, this is 46 times. Every single query is then repeated 46 times. This was extraordinarily surprising to me. There's no other words, no other ways to put it. I'm going to show you another profile. So this is an ISP that is sending everything to the public DNS, doesn't do any resolution himself. And what we see here in the 0 millisecond bucket is that all the queries are going to both Google and Cloudflare. So it's really belt and suspenders. Instead of doing the work themselves, they send everything to Google and everything to Cloudflare. That was also a big surprise to me. Another surprise here, if you look to the right-hand side, the zombies, you see a total of about 37% of queries being replayed more than 30 seconds. Sometimes it's an hour later, sometimes it can be a day or two, or a week later. And you see that those queries are mostly repeated in green, meaning not by the ISP, not by public DNS, but by somebody else. So it could be that this service provider is running some analytics and is sending this to a third party to run the analytics for him. That's possible. Or it could be that the traffic is being sold to a third party to do whatever market analysis they would like to do. Both possibilities are there. Another profile here. So this one also send everything to the public DNS, and you see that on the left that everything is sent to Google and Cloudflare, and about half of it is also sent to Quad9. It's like it's not belt and suspenders, it's belt, suspenders, and something else. The queries to Cloudflare and Google are not repeated at all within the first 30 seconds. But the queries sent to Quad9 are repeated. You see them in the first 10 milliseconds, you see them repeated in 30 milliseconds, 100 milliseconds, and then again, probably on a timeout, at 300 milliseconds and 1 second. And total is huge replication. Why is that? I have absolutely no clue. But what I can say is, this is not what I expected going into this study. So those are like 5 different profiles that we have observed. There are many more ISPs in South Africa that have profiles that are somewhere in between all those things. Back to you, Yazid.
Thank you, Alain. This is quite amazing, interesting. You never know what you will find until you start digging. And this is one of the things I really love in internet measurements. And thank you so much, Alain, for sharing those different profiles and explaining what it actually means and translates into. So what would be your sort of conclusion around those different, cases?
There are different takeaways from this. First, the choice of sending of DNS being resolved by the ISP or by the public DNS is not really driven by the users themselves. Yeah, in a few percent case, maybe. But overall, this is a choice from the service provider. They have decided to either do it themselves or send it to one or more public resolvers. And in some cases that we have seen, they send to two public resolvers in the belt and suspenders way. So that was the first finding. The second one is we see a lot of duplicates, really, really a lot. Either in the categories of what we call the retransmit on timeout, so from let's say 300 milliseconds to 30 seconds, that could indicate some kind of a packet loss problem or some configuration in the network problem. But we also see a lot of them within 100 milliseconds. And that was the most surprising findings for me. Zombies, not typically a problem, but we have seen profiles with every single queries, almost every single query, 97% of them, being replayed a minute, 5 minutes, a day, or 2 days later. And that was also very surprising because I knew that there was some replay going on, but most of the time this is like a small portion of it. Here, of all the queries for that particular ISP during the month, 97% of them have been replayed as zombies. And that was extraordinarily surprising to me. So, how does this compare worldwide? Well, the numbers worldwide are kind of similar. Half of the queries are being repeated within the first 100 milliseconds, and another 30% are repeated between 300 milliseconds and 30 seconds. That's not at all what we were expecting. So the question really is, how come the DNS still work when we have such retransmit rate? And we have to remember that those are unique queries that we send to users. We make up those queries, and each and every one of them is unique, meaning that they are not in a cache. So what we are measuring here is the behavior of DNS when the cache is not in use. So thanks to the cache, because if not, things will be a lot more complicated. Again, as I said, we have anonymized the data. I'd love to have some offline conversation with any of you who is running an ISP and would like to see what we are saying, and we can share some experience on that. Please, Yazid is in the room. I was not able to make this trip. Talk to Yazid. Back to you, Yazid.
Thank you so much, Alain. Wow. I can see a lot of, from the faces, I could see that people seem to have like contributions or comments or maybe questions. We still have like 7 minutes, so it's time to hear from the room what your thoughts are about this study from Alain. And yeah, the floor is yours. Any question or comment, maybe? Oh, none? Interesting.
Moderator's job here.
Oh, okay. Pim?
My name is Pim. I come from Switzerland. I was wondering if there's any pattern to these queries, and if we know what type of resolvers are on the other side when they are private resolvers. Like, are they a DNS dist, or are they a Windows 11 version X on the back end? And so the first question is about the resolvers themselves. You will see those. And then the second question is, do we have any information on like who is making these queries? Maybe for Anna.
Alain?
Yes. So let me step back and explain how the system works. So we distribute through Google Ads millions, hundreds of millions during the month of ads. And each of those ads is a little script that shows a 1x1 pixel on the screen, and that is asked to fetch a few names. Each of those names is unique. It's unique to the actual person receiving this query. So who is making the queries is like random users all around the world. That query goes through the DNS system, so it goes through the resolver or chain of resolver and then end up on Equinix servers. The only thing we know at that point is the IP address of the final resolver in the chain. We have no idea if it's coming from a Windows box, a Linux box, an ISE bind, a NOT, or whatever software. We cannot know that. We could sometimes reverse engineering, but at this point, we do not know that. And then we collect all this information and we group this through the AS number that this IP address is coming from, so we can attribute it to either Google, Cloudflare, or the ISP, or somebody else. That's how the system works. I hope this answered your question.
Yes, I'll ask you another question offline.
Thank you, Pim. Another question or comment? Are those patterns familiar to you or not? Okay, I see no comments. I see no question. So, Alan, maybe one last comment from you.
As I mentioned earlier, this is the very first time I'm sharing those results worldwide. Not even all my teammates have seen them. So if you have any feedback, please give them to Yazid, and Yazid will relay them to me.
Thank you so much, Alan, and we all wish you a fast recovery. And let's keep in touch. See you. Thank you.
Thank you.
Thank you.
I have a gift.
Oh, okay.
Thank you, Yazid.